All right, part two. So, like I said in that last video, now we're going to learn how to factor an ax squared plus bx plus c scenario, specifically when we cannot factor it out any further than that, right? So again, ultimately, we're trying to figure out how can we factor out something like 3x squared minus 20x plus 28, right? There's no common factor that we can take out of all of them. So how can we do something like that? So that is our ultimate goal. But before we do that, we got to talk about some things before that. Like I said. All right. So how can we factor this example? So we got x squared plus x plus, or times x plus 3 plus 5 times x plus 3. So this time, instead of thinking about each of these terms individually, we can think of them as a total, right? So this is one term, and this is one term. And we can know that they're terms because they're all being multiplied by each other. So in this term, in the first term, and the second term, what is in common with both of those? So when we're talking about terms, we're talking about what are we multiplying? What's a multiplication that's in common with both of them? So hopefully you can see that x plus 3, right, is being multiplied in both of those scenarios. So if we take out an x plus 3, what times x plus 3 is x squared times x plus 3. Hopefully you can see that's x squared, right? X squared times that x plus 3 is what we get. Plus, what are we left over when we take out the x plus 3 on that one? We see that we're just left with 5. All right. Now, can we factor this? So remember, we want to always factor completely. Can we factor this x squared? Basically, anytime you have a square or higher, you need to ask yourself, can we factor this? So we look at our factors. Our factors are 1 and 5. And we can also see, right, with the negatives, they're -1 and -5. So here's the question. What do they have to add to be? Where's our x term? There isn't one, right? So if there's not an x term, what number is going to go in front of that x? Hopefully we can all see that that's 0, right? 0x would just be 0, and that would make everything disappear. So we need these numbers to add to get 0. So if we add 1 plus 5, we get 6, not what we wanted. If we add 1 and -1 and -5, we get -6, also not what we wanted. Since there's no other factors, we can see that this is prime, so this actually is already simplified. That's as factored as it can go. Let's do another one. All right, so we got x times y plus 4 minus y plus 4. So what's in common with both of these terms? Hopefully we can see y plus 4 is in common. So a lot of people, when you take that out, a lot of people are going to say it's times x, and we're done. But obviously, x times y plus 4 is not the same as x times y plus 4 minus something, right? That doesn't make any sense. So you need to take those extra steps, right? So we got to say what times y plus 4 is x times y plus 4. It's that x, like we already said. And then what times y plus 4 is -y plus 4. It's actually -1. So that's super important, right? It's not just x. That term doesn't just disappear, right? It's 1, or -1 in this case. We need to make sure to remember that. Cool. So a big thing that we're going to do is we're going to take a step back. So basically what we're doing to ultimately get this, we're going to start with the last step and then keep working backwards. And it'll make a little more sense when we get there. So this is essentially going to be the last step of figuring this out. So let's take one step back and we're going to talk about factor by grouping. So factor by grouping is this. So step 1, we basically group up the terms with a common monomial factor. There will usually be 2 groups. So especially in this class, there's only going to be 2 groups of binomials. So remember, 2-termed polynomials. So if you have 2 groups of 2 polynomials, how many terms you get? Hopefully we can figure out that simple math. That's 4 terms, right? So it's going to be a 4-termed polynomial, ultimately, more or less, kind of. Yeah, we'll see. So there will be 4 terms. You need to have 4 terms to be able to do factor by grouping. So in step 2, we factor out the greatest common factor from each group. And then we need to factor out the remaining common binomial factor, if there exists one. So let's look at step 3. What does that mean, a common binomial factor? Well, it's actually what we just did, right? So in the first case, right, here are 2 groups, already factored things out, and we see that the binomial factor in common is x plus 3. So when we factored that out, we are left with x squared plus 5. Same with this one, right? The common binomial factor is y plus 4. And then we have the x minus 1s left over. All right, so that's why I said we're kind of working backwards. So let's look at this. So we got x cubed plus 4x squared plus 3x plus 12. So the first thing we want to do is we want to group them up. So we group the first 2 and the last 2. So in the first term, what is in common? What's the greatest common factor of just these 2 terms? So hopefully you can see it's x squared, right? So what times x squared is x cubed, x. What times x squared is 4x squared, just 4. All right. And then what about the second term? What's in common with both of these? Hopefully you can see 3 is. So step 1, this is our step 2. So what times 3 is 3x? X. What times 3 is 12? We see it's 4. And then step 3. Out of these 2 terms, right, what's in common with both of them? So if we did it right, we should see that one of these 2 things are in common. And really, we do, right? We see that x plus 4 is in common with both of them. So then what's left over? We got an x squared and we got a 3. So that's our final answer. Except we need to check this one, right? X squared plus 3. I'm just going to go ahead and let you know, anytime you have a square plus a number, this is prime. It's always prime. So if it's ever x squared plus some number, that's automatically prime. I'll just let you know that. There's a freebie for you. So yeah, so that is completely factored and we're done. All right, let's do another one. So we get xy plus 5x minus 4y minus 20. So I'm going to show you the incorrect way to do this problem. This is incorrect. So hopefully at least we can see it, right? This is not the correct way of doing it. Not correct, and we'll see why. So if I group these up, right, like this. So hopefully some of y'all might have already seen what the problem is that I did, but if not, that's fine. Let's just see what the problem is when we do this. So what's in common with the first term? We see x, and what's left over? Y plus 5. What's in common with the second term? We see it's positive 4, right? So if we take out a positive 4, what are we left with? Y minus 5. So then the last thing, what's in common with both of these? There's nothing, right? This is x plus 5. This is x minus 5. You can't do anything. So that is why that was incorrect. Now, let's actually explain what was the incorrect thing. So the incorrect thing that we did was grouping. We grouped them incorrectly, right? And it was this second term right here. That was what we did incorrectly. Because if you notice, it's just supposed to be negative 4 minus 20, right? But if we actually factored out that negative into this, right? If this is this the same? You can see it's not. If we do the negative to both of these, we end up with negative 4y plus 20. So we've completely changed this problem, and that's why we got it wrong. So the better way to do it, the correct way to do it, is as follows. You want to make sure that you are always adding these 2 numbers. Always. You always want to make sure that you are adding these 2 groups. What are you always doing? You're adding the groups. So a way that we could write that, if there's a negative right here, right? If there's a negative right slap dab in the middle, a way that we can write that is xy plus 5x plus negative 4y minus 20. And that is how we're going to group them up. We need to include the negative into this, right? So the problem was that we didn't include the negative. You also want to include that negative and make sure you're adding between them. Now, when we factor out, right? First term, factor out an x, you get y plus 5. Second term, you notice it's actually negative 4 is in common with both of those. So then you get y plus 5. And now we have those binomial terms in common, right? What's that binomial term in common? Y plus 5. What are we left with? X minus 4. All right. So hopefully that made a little more sense. If not, it's totally cool. We have way more examples just like that. All right, so we're actually here. This is all we're doing for this example. So way quicker than the last video. All right, so we are at the point. So how do we factor this thing? So step 1, we want to multiply the leading coefficient a by the constant c. So the number in front of the x squared, we want to multiply it with the number by itself. Then we want to find two factors that of AC whose sum is b. So another way to say that is what two numbers multiplied gets you a times c and adds gets you b. And this might sound familiar because we actually did this, right? If it was, because remember, in the case where we were talking about x squared plus bx plus c, we said what two numbers multiply gets you c, but if we notice, that's 1 times c, right? So we're actually doing the exact same thing that we did in this case. And then what two numbers add gets you b. Also, here's a trick of the trade. If you only have one of these numbers as negative, just make m negative. It'll make things a lot easier. And it's based off of what we just did, that previous example. We'll make the first term negative just to make things a little easier. So let's actually pause on this. Let's look big picture. So we know how to factor by group with 4 terms, right? That's what we said. We said we needed 4 terms to do group factor by grouping. However, if we have ax squared plus bx plus c, where's the 4 terms? There's not, right? We don't have a 4th term. So basically what we need to do is we need to figure out how can we split this up to where we get something nice when we factor by group it. So for instance, if we go back to the example we keep talking about, right? If we have 3x squared minus 20x plus 28, how can we split negative 20x so that way we get something that's good and factorable? Are we going to do it as 3x squared minus, so we could say minus 15x minus 5x, because when you add these two together you get negative 20. Is that going to be the way to do it? Is it going to be 3x squared minus 10x minus 10x? Is that the way to do it? Is it 3x squared plus 40x minus 60x? Is that going to give you something good? Right? Because this also, when you add those two together, that's going to get you negative 20. So how do we know what's going to be the best way of getting this? So hopefully you're all seeing bigger picture what we're doing and why we're doing it, right? We need to know how can we split up this middle term to get 4 terms, so that way we can factor correctly, right? We can do the factor by grouping. So this is the steps of how to do it. So if you notice, right, those two numbers that we figure out, when we add them together, we end up with that middle term. So how about we, again, take a pause in this, and let's actually go step for step into that example that we did. All right, so here's that example that we've been talking about for a while now. So step 1, multiply a times c. So step 1, a times c is going to be 3 times 28. So 28 times 3, 4, carry the 2, right? 24. 3 times 2 is 6, plus 2, 84. So basically we need to know what two numbers multiplies gets us 84, adds gets us negative 20, gets us that middle number. So what two numbers do we end up with? So let's think about this. So we got 84, so 1 and 84. Ooh, of course, it's negative, right? So these are probably going to be the negative forms of them. So -1, -84. When you add those, we get -85, so not close. What about 2? So 8 divided by 2 is 4. 4 divided by 2 is 2. So if we have the both negatives and add those together, again, that's -44. Not great. What about 4? Right? So 8 divided by 4 is 2. 4 divided by 4 is 1. So if we add those two together, we get negative 25. Also not great. We're getting closer, right? Because we need -20. So would -5 work? Definitely not, right? 84 doesn't have a 5 or a 0. -6? Maybe. So let's try it. So 84 divided by 6. So 6 goes into 8 one time. Multiply, subtract. So we get 2. Bring down the 4. 6 goes into 24 4 times. Multiply, subtract. All right, so 14. When we add those two together, we get -20. Aha, we found it. So since both of them are negative, it doesn't matter which order we do it in. We can do it in any order and we'll get the exact same thing. So -16, -6, -4. All right, so we did step 2, 1 and 2. All right, step 3. So let's rewrite that middle term, bx, as a sum or difference between the two numbers that we found. So we said that m plus n is b. So that means ax squared plus bx plus c is the same as ax squared plus mx plus nx plus c. So this is how we're breaking up that middle term using the numbers that we just found. So for this one, right, we have 3x squared minus 20x plus 28. But what numbers did we say can add together to get us -20? We said it was -6 and -14, right? These were our numbers. So we can just split that apart into 3x squared minus 6x minus 14x plus 28. Right? Because -6 plus -14 is -20. So we haven't changed anything. All right. Now that we got 4 terms, what are we going to do? Last step, factor by group this thing. All right. So, okay, so here's the case, here's the thing. How are we going to group these up? We group them like this, right? Hopefully all of y'all said no. So what's the problem here? Remember, there has to be adding between these two. So we can add a negative. So we want to include that negative into the second term. Good. First one, take out a 3x, right? 3 is in common, x is in common. So x times 3x is 3x squared, minus 2 times 3x is -6x. All right, what's in common with -14 and positive 28? So since this one's positive, we also want to make sure that this x is positive. So maybe -14 can be divided by both things, right? So 28 divided by 14. Well, if we notice, this is exactly double, right? 1 times 2 is 2. 4 times 2 is 8, right? 14 plus 14, 28. So 14 times 2 is 28. So yeah. So we take out a -14, then we end up with -2, which, that's what we wanted. So when we take out the x minus 2, what are we left with? 3x minus 14. And that's our final answer. Since we don't have any squares left, we're all factored out. So that's how you do it. So let's just do a few more examples, make sure we get a gist of this. And this is it. This is all we're doing for the rest of the video. All right, so we got 8x squared minus 10x minus 3. So can we factor anything first? Nope, there's nothing in common with anything. So, all right, Let's look at these two things. So what two numbers multiply gets you 8 times negative 3? So what two numbers multiply gets you negative 24 and adds gets you negative 10? So what are the factors of negative 24? We see it's 1 and negative 24 and vice versa. We see that it's 2 and negative 12. We see that it's 3, negative 8, 4, negative 6, and we can put those negatives on either place, right? So after going a little while, hopefully you'll see that this is our case, right? 2 plus negative 12 is negative 10. So notice, one of them is negative, so let's make the first number the negative 12. Negative 12. It super doesn't matter, but remember when we group things, if the second number is going to be negative, you have to include that, and it just makes it a lot worse. So the trick of the trade, always make the first number negative. It just makes things a little easier. All right. So step 3, rewrite everything. So 8x squared minus 12x plus 2x minus 3, right? Notice if we had switched those, we would end up with the same answer. It would just have the bigger potential to mess things up, right? If we don't include that negative. Cool. So factor the first one, factor the second one. What's in common with the first term? We see that we get 4x, right? What times 4x is 8x squared? 2x. What times 4x is negative 12x? Negative 3. There's nothing in common with the 2x and the 3, but that's good because if we notice, that's what's in common with both of these, right? So if we take out 2x minus 3, what are we left with? Just 4x, right? Hopefully all y'all are screaming no. Good, because it's a 4x plus 1. So on this right here, on this step, if you notice that there's nothing you can factor out, remember you can always factor out a 1. So if that's helpful for you, just say, yes, I factor out a 1, nothing's changed. And so that way, when you do the last step, you can actually see, okay, it's 4x plus 1, not just 4x plus 0. Good. That's it. We're done, right? There's no square. You can't factor anything else out. All good. All right, so let's do a weird one. Woo! All right, so for all intents and purposes, we can just ignore all the variables, right? This is going to be the exact same as it always has been. So step 1, do 2 times 3, which is 6. So what two numbers multiply get you positive 6 and adds get you negative 7. So it may take you a little while to finally get into the rhythm of these. That's why we're doing these a million times. If you want to just pause it and try to figure it out on your own, that's fine. But we'll see that it's negative 6 and negative 1, right? Negative 6 times negative 1 is positive 6. Negative 6 plus negative 1, negative 7. So we can, step 3, let's split these up. So we're splitting up the middle term. So make sure you include all the variables with the middle term. So we get 2x squared minus 6xy minus 1xy plus 3y squared. When we group them up, what do we have to remember since it's a negative? We have to remember to add, right? Add the negative. Include the negative inside. Good. What's in common with the first term? 2x. What are we left with? X minus. Right? X times 2x is 2x squared. And we get what times 2 is 6, 3. X stays, so we're just left with that y, right? Here's a negative, not great, so let's take out that negative. And we can also see in common with both of these is going to be that y. So negative y. And what are we left with? What times negative y is negative xy? So just x. What times negative y is positive 3y squared? Well, it has to be a negative, right? So negative 3y. That's great because that's what we have in the other term, right? So we know we've done it right. This step can be a good way to double check yourself. If you don't have the same numbers, you've done something wrong. Go back and recheck what you've messed up on. I did this while I was practicing this too. Sometimes I would get the m and the n wrong, or I would get the mn, right? I'd multiply these incorrectly somehow. So just go back, double check. If these aren't the exact same, then you can't keep going, right? You've done something wrong. That's a good place to check yourself. But if you do end up with the same thing, x minus 3y, what are you left with? 2x minus y. That's our final answer. All right. 3 more examples, and then we're done. So just to get our practice, we got 2 times negative 6. So again, if you just want to pause this video, try to figure it out on your own, fast forward it, see if you get the same answer that I do. That's perfectly cool. That'd be a great way to practice this. So when we multiply these two together, we get negative 12. So what two numbers multiply gets you negative 12, adds gets you negative 1. Because remember, this is an invisible 1 out front. So hopefully you can see the answer would be negative 4 and positive 3. Notice I did the negative in front, the first number, because it just makes things easier on you. So step 3, 2x squared minus x minus 6. That's the same as 2x squared minus 4x plus 3x minus 6. If we factor things out, what's in common with the first term? 2x. What's left over? X minus 2. What about the second term? What's in common with both of those? Positive 3. What's left over? X minus 2. Yeah, don't just assume it works. Actually make sure. X times 3 is 3x. Perfect. Negative 2 times 3 is negative 6. Good. We can see we do have something in common. We have x minus 2 in common, and what's left over is 2x plus 3. So that's how we'd factor that out. Good. Nope. Did I not do the rest of these? I did not. Whoops. That's bad on my part. All right. Well, we still have 2 more examples, so I guess I'll just write them out. It won't be as pretty, which is fine. All right. So example number 8. So let's factor 8x squared minus 22x plus 5. 8x squared minus 22x plus 5. So step 1, multiply them together. 8 times 5 is 40. So step 2, what two numbers multiply gets you 40, adds gets you negative 22. So we can see that that's going to be negative 20 and negative 2. Again, there's no rhyme or reason for these two. They can go in any order. If you do it in the opposite order and you do it correctly, I bet you can see we end up with you and me will end up with the exact same answer. I guess you and I is the right way to say that. So we get 8x squared minus 20x minus 2x plus 5. We separate those out. Remember, we want to make sure to add that negative to include it in. So what's in common with the first two terms? We can see 4x, right? So we end up with 2x minus 5. So we can see again, this is a positive 2x and a negative 2x. Let's take out that negative and switch all the signs. And really we're taking out a negative 1. So if you want to just go ahead and say negative 1 to help you out, totally okay. So we're left with 2x minus 5, right? What times negative 1 is negative 2x, positive 2x. What times negative 1 is positive 5, negative 5. Which again, perfect. We end up with the same answer, or same, a common term between the two, which is 2x minus 5. What are we left with? 4x minus 1. Good. Last problem. Example number 9. So let's factor out 15y to the 4th plus 26y cubed plus 7y squared. So first things first, we do not have a cube out front, right? We have a 4th. So does that mess everything up? No, right? We can do this. What do we just have to do first? We have to find that greatest common factor. And in this case, you can see since this is a 7, right? 7 is prime. So can 7 go into 15? No, right? 7 goes into 14. So the only thing so none of the numbers are going to work. So let's just look at the y's. So we can take out a y squared. Yeah. So what's left over? 15y squared plus 26y plus 7. All right. So if you just want to go ahead, right? Because now we got to factor this part out. But what do we not need to forget? The super important thing is that y squared at the end. So if you just want to go ahead and go at the bottom of your problem, just say answer, right? Make sure to have that y squared encased in it. It might be a good thing, right? Just at the very bottom, just say y squared and then go from there. All right. So step 1, 15 times 7. I don't know that off the top of my head. So 15 times 7, 5 times 7 is 35. Carry the 3. 7 times 1 plus 3 is 105. When you add the two together, they should get us 26. So after some time, right, you can ultimately see that the answer is going to be 5 and 21. So we got 15y squared plus 5y plus 21y plus 7. So factor them up, or group them up, factor out. First term, right, we get 5y. What's left over? 3y plus 1. Second term, we get 3. So that's, not 3, we get 7, right? 7's in common with 7 and 21. So that's 3y plus 1, which is good because now we got the 3y plus 1 and the 5y plus 7. But because you did this at the very end, you know that's not the answer. You have to include the y squared as well. So again, that just might be a really good way of not missing that y squared. Cool, cool. All right, that's it. I will see you next time for some special factoring. And one of them is very important that we definitely need to make sure we know how to do. So see you in the next video.